Now, for cohesive soil 50 milliliter density bottle is used. For coarse grain soil 500 millimeter flask or pinometer is used. In case of soil with a high percentage of clay, it is advisable to use the kerosene as the weighting material, as the addition of distilled water causes a problem in weighting the soil. Then specific gravity is given by the equation specific gravity is equal to Ws into Gk divided by W4 plus Ws minus W3. Here Gk is the specific gravity of kerosene at the test temperature. So, from this equation also you can determine the specific gravity of the soil. The specific gravity bottle, flask and pinometer are exactly calibrated at 20 degree centigrade. If the test is conducted at any other room temperature, let us say T1 degree, the specific gravity at 20 degree centigrade is also found with this specific gravity G at a temperature of 20 degree centigrade is equal to G at T1 degree centigrade into specific gravity of the water at T1 degree centigrade divided by specific gravity of the water at 20 degree centigrade. So, here I am showing some specimen calculation for specific gravity test. So, you can take the different soil sample number, then you take the empty weight of the specific gravity bottle, okay. Then that empty weight is about 25.340. Then you take the weight of the specific gravity bottle plus soil, that is W2 gram is 42.395. Then the specific gravity weight of the specific gravity bottle plus cell of water W3 in gram 86.716. The weight of the specific gravity bottle plus water W4 in gram is 75.960. Then weight of the even dried soil taken after the correction is Ws is equal to W2 minus W3, this is 17.025. So, then you can calculate the specific gravity and this gravity is 2.72. Detailed calculation is given here. This specific gravity is equal to, this is the 17.205 W3 divided by W4 is 75.950 plus 17.025 minus 86.710. This will give you the specific gravity is about 2.72. So, you can determine the specific gravity of the soil, and this specific gravity of the soil generally it is 2.5, 2.72, 2.8 like this. So, next I will discuss that field density test. So, main aim and objective for field density test to determine the in situ density. This is very important, that how you can determine the in situ density of the soil. Now, the in situ density refer to mass per unit volume of a soil in the undisturbed state of a compacted soil in place. It is very important that one should collect the undisturbed soil sample, not the disturbed soil sample. And then the verification of the result of moisture and the density as achieved through the method of in situ density determination. The method of commonly used, there are defined types of the method. One method is the sand replacement method, and this is the most of the one of the popular method, sand replacement method. You can go for oil replacement method or core cutter method, also very important, and then soil clot method. So, I will just focus some of the method here for the determination of field density of the soil. The underlying the principle of this method is basically the same. First, to obtain known weight of the damp soil from a small excavation of somewhat irregular shape in the ground, and then knowing the volume of the hole, the weight density of the soil can be computed as that gamma weight will be equal to ratio of the weight of damp soil in grams and the volume of the hole in cc. That way you can determine what will be the weight, gamma weight in units is gram per cc. If one obtain the moisture content of the excavated material, the die unit weight of the material can be rapidly computed. So, if you know the weight density, you can also determine the die density of the soil sample. Then sand core method enable determination of the volume of the hole by filling it with the sand calibrated for the unit weight. So, you can excavate and then you excavate and make a hole and then you fill up with the sand. So, it is desirable to have a uniform or one size of the sand to avoid the segregation problem. Generally, the sand passing through the sieve number 20, but retained on the sieve number 30 is used. If the natural soil in the field is very hard and also dry, the core cutter may not be penetrated even with the hammering. Then what could be done? In such a situation, problem is best resolved by taking a soil cod and determine its weight and volume by wax coating method. So, this way you can solve the problem if it is too hard. So, different types of the methods are available. So, depend upon the type of the soil you can adopt and can determine the properties of the soil. So, for this kind of the testing, so we require certain apparatus and the accessory required. That is sand replacement apparatus, you require sand pouring cylinder. I will show you in the next slide that what is the sand pouring cylinder, and calibrating the cylinder and metal tray with the central hole. While sand, which is standard 4 inch diameter, 100 millimeter diameter post hole auger, then you require spatula, weighting balance to weight up to 10 kg with a 0.1 gram accuracy. Then you require moisture can, you require dyeing oven, core cutter with the dolly and lightweight hammer, and the screwdriver and the straight edge. So, these are the mainly the apparatus what you require. I will show you that in the slide what are those apparatus required. Here you can see that this is the core cutter, and this is the sand replacement that apparatus, this is the dolly, and these are the post hole auger in which you can bore into the soil, and this is the oven in which you can dry the soil sample, and this is weighting balance you can measure, and this is the moisture container in which you can keep the soil, and you can measure the dye weight and the weight of the soil. And this is the white very standard sand, and these are the screwdriver, it is what will be required, and this is the lightweight hammer which you use for the field density. So, these are the apparatus are very important, and we use these apparatus for the determination of the field density of the soil. So, what are the testing procedure? So, first of all that sand replacement method, you require calibration of the standard sand. Fill the sand jar with the standard white sand and then weight. I have shown you that what is the white standard sand. So, you fill up into the jar and take the weight of that white sand. Take a standard measure and you can find its volume. Then place a galvanized tray with a 4-inch diameter center hole over the measure so that hole fit over each other. Place the sand in the jar cone in the tray over the measure. Then open the valve, remove the lid and allow the sand to flow into the measure. Now, close the valve when flow had stopped. Replace the lid and carefully weight of the sand core apparatus. So, these are the way that one has to perform the test. Then place the sand core apparatus on a paper placed on the horizontal table. Open the valve again, open the lid and allow the sand to flow and fill the cone. Close the valve, replace the lid and wait again. From step 6 to 1, you calculate the weight of the sand, filling the measure and the cone. From step 9 and 6, you calculate what will be the weight of the sand filling the cone. From step 11 and the 10, calculate the weight of the sand filling the measure only and find the density of the sand. So, these are the process for the determination of the density of the sample. Now, here you can see sand replacement test apparatus. This is sand replacement test apparatus, and this is the cone. This dimension is 200 milligram, this is 8.5 millimeter, and here is a cutter. this cutter, it can be replaced, and then you can fill up with the sand and you can measure what should be the volume. So, this is the procedure for calibration of the sand. You can see. Now, field test. Level an area of the soil in the open field and place a tray with a 4-inch diameter or 6-inch diameter hole on it. With a 4-inch diameter post agar or bore a hole 5 inch to 6 inch, okay, 125 to 150, and then remove all the material excavated from the hole, place it in the polyethylene sheet and weight it to find its weight. Now, fill the sand jar, cone, apparatus with the standard sand again and take the weight. Place the clean tray on hole, place the sand core apparatus on that. Open the valve, remove the lid and allow the flow into the hole. So, when the flow had stopped, close the valve and weight the sand cone. Knowing the weight of the sand cone from the step 3, 5 and 1, calculate the weight of the sand filling the hole from step 7 and the 4. Determine the volume of the hole by knowing the weight of the sand and density of the sand. So, you know that what will be the volume of the hole, you know that what will be the weight of the sand. So, you can determine the density of the sand. From step 9 and 3, determine the weight density of the soil. Take 2 soil samples from excavated soil about 30 to 40 gram in 2 separate moisture can and determine the dye density of the soil from the field. So, these are the procedure for the determination of the field density of sand replacement method. So, here you can see this is the apparatus, how you can fill up with the sand into this hole and then you collect it and then you determine that field density of the sand by sand replacement method. Now, the specimen calculation for the field density test using the sand replacement method. So, you have to find the density of the standard sand. First of all, you take weight of the sand cone apparatus filled with the sand initially. Let us say that weight is equal to W1 is equal to 8095 gram. Then weight of the cone apparatus with sand after release of sand in the standard container. Let us say weight is W2 and this is 6310 gram. Therefore, weight of the sand container and cone W3 is equal to W1 minus W2 is equal to 1785 gram. Then weight of the sand and apparatus after release on flat surface, that is W4 is equal to 5865 gram. So, therefore, weight of the sand in the cone is G is equal to W4 W2 minus W4 is equal to 445 gram. So, this is I am just focusing here that some calculation for field density stress using the sand replacement method. Now, you know that what will be the volume of the standard container, and that is very standard, then volume is equal to 957 cc. Now, weight of the sand only in the standard container W is equal to W3 minus W2 is equal to 1340 gram. Next, density of the standard sand used, that means gamma sand is equal to W by V, that is W is equal to 1340, this divided by that volume is 957. So, this density of the standard sand comes 1.40 gram per cc. Now, in case of in situ density of the soil, weight of the sand cone apparatus filled with sand, let us say that weight is W1 and that is 8130 gram. Now, weight of the sand cone apparatus with sand after release in the pit and cone, that is W2 is equal to 5550 gram. Therefore, the weight of the sand in the pit and the cone can be calculated. W3 is equal to W1 minus W2 is equal to 2580 gram. Now, weight of the sand filled in the cone is 445 cc. Weight of the sand filled in the pit alone is equal to W5 W3 minus W2 2135 gram. Weight of the wet soil collected from the pit, that is W is equal to 2532 gram. Dye density of standard sand used from the step 8 determine the density of the standard sand, that is gamma sand, you know earlier we determined that is 1.40 gram per cc. So, volume of the pit, that is V Ws by gamma field is equal to 2135 divided by 1.4 is equal to 1525 cc. Weight density of the soil, that is gamma m is equal to weight divided by volume, W by V is equal to 2532 divided by 1525 is equal to 1.66 gram per cc. So, moisture content of the soil M is 27.4 percentage. Dye density of the soil gamma D also you can determine knowing the moist density of the soil, that means gamma D is equal to gamma M divided by 1 plus M divided by 100. That means that moist density is 1.66 divided by 1 to 7.4 into 100, and that gives 1.3 gram per cc. So, gamma m is the weight density of the soil. Then specific gravity of the soil we have determined, that is G is equal to 2.65. Then from this data, dye density and the moisture content and the specific gravity, you can calculate that what should be the void ratio of the soil. So, void ratio has a relation with the specific gravity and the dye density and the weight density of the soil. So, void ratio of the soil E will be equal to G gamma W divided by gamma D minus 1. You know that density is about 2.65, in gamma W is 1 divided by gamma D 1.30. So, it gives the void ratio of the soil about 1.038. Now, also you can determine that what should be the porosity of the soil, and porosity is generally designated at N and in percentage. So, porosity has a correlation with the void ratio. That means, porosity N will be equal to E divided by 1 plus E, that into 100, that is 1.038. This divided by 1 plus E is 2.038 into the 100. So, porosity N is about 50.92%. So, you can determine, knowing the value of the moisture content, density and the void ratio, porosity. Apart from that, you can calculate that what will be the degree of saturation, that is S. That is also very important parameter. So, degree of saturation is equal to G into M divided by E into 100. That means, you know that what will be the specific gravity of the soil, that is 2.65, moisture content is 27.4. This divided by the void ratio E is equal to 1.035 into 100, that means it is 69.95%. So, knowing this density, dye density of the soil, moist density of the soil, specific gravity of the soil. So, you can calculate that what should be the porosity, what should be the void ratio and what should be the degree of saturation. These are all the very important parameters which one should know how to evaluate, and this will be very much useful for the design of any structure which is based on the soil. So, there are other method also which you call the core cutter method. So, take a core cutter standard dimension and determine the volume of by knowing its diameter and the height, and weight the core cutter and record the weight. Secondly, oil the core cutter from inside, and thirdly, place the core cutter on the freshly prepared plain ground with the top cap dolly on it and gently hammer it until the cutter is completely pushed into the soil. Thank you.